Welcome. In this week, we have been talking about Spark SQL. So, in this module, we are going to get introduced to the Spark SQL lab. We are going to start with a data set and a business need in order to start analyzing the data set. And then I'm going to sort of give you a Spark SQL demo on Databricks. So we are going to take a look at two kinds of demos. One is how do we actually load the data set. So the data set in this case would be in a series of CSV files. So how do we load them? How do we make SQL tables, views, and common table expressions, right? So that will be the first part. And then we are going to talk about, which is again a review in some regard of what we have already done in the RDBMS data model section. We'll talk about SQL joins, functions, set operators, etc. As a refresher. So let's get started. So instead of talking about a lot of theoretical aspects of Spark SQL, we are going to get hands-on on it. So we are going to use the Databricks platform to get hands-on with Spark SQL. So the first activity will be how do we load a data set, right? By creating SQL tables on Spark from CSV file. So we'll talk about how if the schema on read actually happens, right? How schema can be inferred or can be specified while reading the file. So this process will also help you to connect the dots of how can we use Spark to create this data warehouse, right? So you do, especially when you don't have the infrastructure to create a separate data warehouse, then how you can think of Spark as a processing engine to do your data warehousing activity. Then comes storing your SQL query results, right? You can use your Spark tables, your Spark view, or your common table expression, which are essentially temporary views, right? How do we can load the CSV file and query from these tables to create more tables, more views, and what are the differences and what are common table expressions. And then we will review the SQL, some of the properties of SQL itself, such as join, what are the different kind of joins, functions that are there, aggregate functions especially, use of set operator in your SQL, what are the advantages and disadvantages, etc. So let's get introduced to the data set next. So for this lab, we are going to use the Adventure Works dataset. So this is already in the fact dimension star model dataset. So for each of these tables that you see, the fact table, the center fact table is the fact internet sales, and there are multiple associated dimension table, your dim customer, dim promotion, dim date, dim geography, etc. So we are essentially, there is a CSV file for each of these tables, right? So we are going to start loading them. So in our case, there is always, as I said in your project as well, it's good to start with an objective in mind. So the management wants to get some business insights into this data. Okay, so what specifically they want to look at is understanding sales and customer behavior. Okay, because they eventually want to create a machine learning model that predicts what a customer will purchase, right? Based on their behavior, they want to know what will the customer purchase, right? So this is the goal, but we are going to do the exploratory data analysis, or what we call the EDA, for this data set. All right, so let's get started. Welcome to the Spark SQL lab. In the first segment, we talked about multiple ways to use Spark SQL, right? So we are going to use, as always, Databricks because it's a service, the community edition of Databricks, in order to do hands-on and try out our Spark SQL and learn a little bit more about it, right? So as we had mentioned, the first way is to use the data definition language, the DDL of SQL, in order to read the schema so that you will be able to query your CSV files.
right? So first, I just wanted to make sure that you have, so you would have access to Spark SQL Lab, right? So that is the file, and you will also have access to Spark SQL Deep Dive. So these are the two notebooks we are going to go through. And then you will have access to the data, all right? So which is a bunch of CSV files. So as you see the CSV file, you can already see that it's a data warehouse data, because some of the data are dimensional data and some are fact data, right? That is what we got introduced to the data set. We are going to use the Adventure Works data set. So very quick call out, some of these labs are modified and adapted from Brian Kafferty's notes. Great thanks to him. Please do go and look at his module. I have adapted it to the curriculum that we are doing here. Right, so but they are great source of resource if you want to get deeper into it. Okay, very quickly, so if you haven't loaded your notebook, you need to go to workspace, pick the user. So first log on to your community edition of Databricks, right? So very similar to the earlier one. So then you go ahead and do an import and drag and drop your Spark SQL lab file. So since I've already loaded, I'm not going to go ahead and do that. So for this lab, you not only need to load the notebook, you also need to load the data. So we know, so go to your data tab and then do a create table. So this will open up, right? So you can essentially drop files in there, which is all of your data files, right? You can just drop. Since I have already done that, I'm not going to go ahead to do that again. Okay, so once you are ready, so open up your workspace, so which is the SQL lab, right? So firstly, I have already connected it to a server. So if it is not connected, you can create a new resource and connect it. Okay, so first things first, we are going to create a new database to load all of our data into it. So first thing is very important to understand in Databricks is this is a community edition of Databricks. So we are not connecting it to our cloud account like your GCP or your AWS or your Azure account, right? So this is available free to us. So every time your data warehouse, after you load it, you will have to sort of reload the data every time you want to query it, okay? Because after a few hours, if you're not using your notebook, your session will get given to somebody else, right? So you'll have to reload it. But since you have the CSV file, it is just a matter of running these queries and again. Okay, so I'll also repeat this in the end, but it's important for you to understand. So we are creating a database. So create database, if not exists, AW, which is Adventure Word, right? So we are running that. So it's taking a little bit of time. Okay, so then we are changing the database context. So once we have created, we are going into the database. So we are saying use AW project. Okay, so we are going to create all the dimensional tables first. So one of the key differences, as we have talked about in our slide, right? Spark is not an RDBMS. So that is the very important difference. Spark SQL is not RDBMS. So it doesn't take care of any of your inferential data integrity, right? So it's up to us to load data in the format that makes sense to us. So we are going to first load the dimensional data, because dimensional data contains all of your date information, customer ID information, geographical code, etc., which will eventually get used in the fact of your sales fact, right? Spark doesn't keep track of these relational data or the data integrity. So it's up to us to load it in the right way. So it's okay if you load your fact table first. So Spark is not going to complain really, but just ensure that when you're using Spark is not going to check on the data integrity aspect, right? It's up to us to make sure that our data is integrated. So because we are doing, Spark is a data processing engine really. Okay, so we are creating the dim data. So very quickly, I'll look at the syntax of it. So we are saying create table dim data, standing for dimensional data using CSV. So because once you load your data, it always goes to the file store table where it's this thing. So here, this is where we are doing the infer schema. So we are saying the file has a header and please infer the schema from it. So very quickly, I'm just going to go and open up the dim data file for you so that we can see if there is a header, right? So this is what you do if your CSV already has a header. We'll see an example of, right? So you have the date key, the full date alternate key, the date number of weeks, all of these. So it's going to infer schema from it, right? So Spark is smart enough to do that. And then once we load it, we are going to select start from dim date, sorry, not data, date, and just limit to. So let's run this query. So it's going to take a while. So here again, later in the course, we'll talk about the execution plan that Spark creates, right? So this the execution plan is what creates these steps, the DAGs itself. Okay. So just for another example, we are going to load in the DIM customer data, right? So again, we are asking it to infer schema. Go ahead and do that. All right, so you can see that data after it's loaded. All right, so for the rest of the tables, I've asked you to do it yourself. All right, you can play around with these options of header, false, infer schema, false. What happens? We're going to take a look at it. So in my case, I'm going to run all of these, but you will not have code for it. So I'm going to show you how it looks after all of your dimensional tables are loaded. So let's I'm going to quickly run all of it so that it is that's it. So in your case, you will have to write the code to load. Okay, so while all of that gets loaded, so next is your fact table. So there is fact internet sales table, and then I think fact internet sales reason table. So here we are creating the fact table, right? So we are using the fact header, infer schema, that is all fine, right? So in the event we are not inferring schema, right? So you have to specify what are all the columns, right? So we can create table. So in the second fact table, fact internet sales reason, we are saying sales order number string, sales order line number integer, and sales reason key integer, right? And we are saying header false and infer schema false because we are specifying what is the data type for each of the columns, right? So this also, so let's wait for it to run. So this is also giving us, so you can specify the schema explicitly instead of talking about inferring schema. Okay. So now we have loaded all the dimension and fact table. So now we can query the SQL tables that we have created. So the first query we are going to look at it is looking at the product data where the status is current. So the product category key from the DIM product category, product subcategory key from DIM product subcategory, product key, right? So it is joining multiple tables, three tables actually. So your DIM product is the main table, then your DIM product subcategory, product category, right? Based on the keys. So let's go ahead and run this. Okay, so these are the 67 rows that are getting returned. So with the output of a query, you can create a table, right? So because what happens is if you want this table to be kept in order to use it for your analysis further on, right? So you already join these tables in a certain way. So if you want to keep it for further analysis, it makes sense for you to create a SQL table. So here we are going to create a new SQL table which contains the data from the previous query. All right. So in this case, we are so every time we are just checking if a table exists. If it is not, if it does, we are dropping it. so that we can create your table. So we are creating a table product info as, and the whole select query that we have shown earlier, right? So that is what we are using, right? So this is going to create a table t underscore product info in order to your SQL table gets created from an SQL query itself, right? So, of course, the execution plan of this is a little bit more elaborate because you'll first have to create the data and then create the schema for the table, right? And then once a SQL table is created, you can use it as any other table. You can do a select star to see what is the output from it, right? So one of the key differences between SQL table and an SQL view is that the SQL table will extract the data and just put it. But if your CSV files change after that, it will not get reflected. Whereas if you create a view, then whenever your CSV files get refreshed, right, the view also will get refreshed. Okay. So, of course, once you are creating a SQL table, you can, of course, query it directly as well, all right? Not just do a select star. So here we are looking at all the group by the model, subcategory and category. We are counting the number of products which are there, right? So there are 41 rows in here, 41 different types of models. So welcome back to the Spark SQL lab. So in the earlier demo, we sort of created the data warehouse using the CSV files from the Adventure Work dataset. All right. So now, and we created the SQL tables, CSV files, and then we also created a SQL table which contained the results of a query from the data that was loaded. So next we are going to see the difference between SQL table and SQL view. So we are going to create a new SQL view. Right. So just to differentiate between table and view, so the T underscore is to indicate a table, whereas the V underscore is to indicate a view. So we are going to create a customer info view, getting all the information from regarding the customer. So the key difference, as I was stating earlier, of the view from the SQL table is that in a view, it will keep refreshing data when the underlying CSV file is updated. However, in a SQL table, it does not. So once the table is created, it doesn't change. Whereas the view is attached to the data file indirectly, right? So the syntax is fairly simple. So in the place of table, so select or replace a table, we say select or replace view, right, as, and then it follows by the query from which you need to create the view. So once you create the view, you can of course query it just like you would query your table. This dim customer sort of comes from the dim customer.csv. So if we change the dim customer CSV, so your view will also change. Okay. So I just wanted to talk a little bit about some of the categorical data, right? So some of the quantitative data like age or salary, etc. So you might want to categorize it so that we can do analysis of it in some specific way, right? So in this case, we are going to create a view that uses a case statement. So this is more of the SQL aspect of it, but just to illustrate the point, right? So if you're creating a view of the sales information, so this is basically your order date, your due date, etc. From essentially your fact internet sales table. But what is important here is there are two columns. One is the number of children at home. So we are converting that into a binary column, or rather a yes or no field, right, from the number. So if it is greater than 0, then it's Y, else N. And we are aliasing that as children, right? And then we are also looking at age. So age less than 18 is going to be created as minor, whereas between 19 and 29 as young, between 30 and 39 as middle, and 40 and 49 as late middle. All of that is going to be created, and age greater than 50 is considered golden and as age band. Okay, so it basically joins all of these. So it's joining your fact internet sales, and then the um, view customer that we just created above, then the product info table that was created, and your dim date table, right? So you can see that once it's all in the Spark system, you can do multiple joins. So you can do joins from table to view, etc., right? So that flexibility is available. So let us give it some time. So this is basically created the view, right? So we are going ahead and querying the view, right? So I want to just show you the new columns that we created. So some of the columns that we have created are your has children column, right? So that was N and Y, right? So you can see that comes from the number of children column. So it's no longer going to be number of children, and the age band column, right? So that shows the categorical data. So the idea here is to just demonstrate that you can do your query of multiple things, but your view is going to be temporary because it's connected to the data. So there are two kinds of view. One is a view, the other is what we call a common table expression, CTE in short. So what common table expression essentially is a more temporary view, right? So what happens is your query itself, you can put it, give it a name called a common table expression, so that you can use it within the execution block, right? So just to indicate, so it's like a temporary table. So how do you create the common table expression is, so your CT is check months. So that is the common table expression you're creating, which has the results of this query. So select your fiscal year, month, number of year, and count number of sale from your sales info, which was a view that we created. All right, group by your fiscal year and number of years, and order by that. And then using this, now we can query, right? So this is a very temporary view that we have created, which is your common table expression. So common table expression is temporary only within this because it's executed together, right? But if I try to query from your common table expression, so if I try to query it, so it's going to just throw me an error. Okay. So in the view, so view essentially is not having the data, so it's connected to the file itself. So if you want to save any of your views into table, especially if it is connected to a cloud service provider, right? So you want to persist the data essentially, which is meaning you want to save the data on the view to keep it, right? So then you can convert your views into table. So here we are replacing the table T underscore customer info as select star from V underscore customer, which is the view that we created. So the same is with regard to your uh, this thing. We are creating a table uh, T underscore Salesforce, right? And which gets us information from V underscore Salesforce. So V underscore Salesforce is that complex query which did a lot of joins, right? Just to go up, I'll just show you what that query was. So this was the view that we created, right? Which is from the fact internet sales, which joined V customer, T product info, dim date, right? So the error is basically because of the common table expression. So I'm just going to. So once you have persisted data into table, then you can choose to delete the views itself, right? So that is something you can do. So this, of course, is going to take a while because so you can see that some of the Spark's job has multiple steps to it, right? So we'll talk about that when we understand the Spark execution plan that happens. Okay, so finally is we can drop the views um, from your Spark SQL. Okay, so in this lab, you have a few exercises which talk about how do you get sales by customer education, a few other exercises. So those are for you to go ahead and try. Okay, so I've given you a few exercises, and there is one more which is essentially to create query for three of the business problems. We already talked about some of the business problems. So this you have to specify what are the data you want to capture and write the corresponding query for it. Okay, so based on what the business has asked for. So this is what you will be submitting as your assignment. So I'll specify all of that. So please do go through the entire week's information because you can choose to do it as SQL table. In the subsequent lab, we'll also talk about the PySpark data frame. So you can choose to do your assignment in either of these ways. All right. So yeah, so that sort of ends our first demo. This demo essentially looked at the views and common table expression and how do we convert our views into tables and how you can actually query joining your tables, views, etc., all in one go. Welcome to the Spark SQL deep dive. So in this demo, we are essentially, it's going to be a fairly quick one where I'm not going to go through multiple queries. It is for you to try it out. But I'm going to talk about some of the features of which is a good refresher, and it's also one of the very important skills I always specify as a skill to a student because SQL test is a very, very important part on any of the technical interviews, right? So you don't, there isn't enough practice of SQL that you can miss out on. So at any SQL stage, I always make sure that there is sufficient practice and recall of certain things so that it will also help you while you are attending your interviews, right? So this was made in that context. So this is the Spark SQL Deep Dive Lab. If you look at this folder, so you have your deep dive. So you know by now how to locate your load your notebook. All right. So for this, you should have already created all the data in your database, basically the dimensions tables and the fact table, right? So once you have done that, so we are going to just use the adventure work project database. So the first thing is we talk about join. Of course, we've already talked about, we have already executed a few joins, but this is a good time to reiterate the importance of join. Join is when you are collating data from multiple tables. So there are four main types of join, inner, left, right, and outer. By default, whenever you say join, SQL does an inner join. So inner join is where the rows which have correspond rows in table 1 that has corresponding call rows in table 2 based on the joining condition, the on condition, right? So only those rows are returned. So any rows in table 1 which don't have corresponding rows in table 2 are not returned. Any rows in table 2 which don't have rows in table 1 doesn't get returned. So that is very important. So a good way to understand it is using your set theory, right? So it is the intersection. So I just wanted to help understand the inner join. So inner join usually results in a complete data set, right? So you have information which is readily available. Here we have join product. So the product keys come from the product table and the product name, and the product subcategory sort of comes from the product subcategory table. So the next we do a left join. In left join, the left table is the most important, right? So the left table is taken as the reference, and all the rows of the left table are present, and the corresponding data from the right table, if it is present, it will get data from the right table. So in this case, dim product is the left table. So dim subcategory. So if this particular subcategory didn't have the subcategory data, right? The corresponding key, so it is not going to return anything. So here, if you look at it, you do see there is some null value, right? Your subcategory value is null because your product subcategory ID is null. So that is not defined in your dim product subcategory. So this is also a good representation to understand. So here, of course, we are limiting it to 3. So the on join, you should know how many rows will get returned, right? In this case, if we didn't do a limit, the number of rows will be equal to the number of rows in your left table, which is your dim product. So here you can also see how Spark SQL is not a relational database, right? So we are not taking into consideration all the category subcategory ID needs to be in the dim product subcategory table. So then comes the right join. It is essentially the same as your left join, except that now your right table is your reference table. So here we are joining from product subcategory and we have flipped it, right, and right join dim product. So dim product becomes the reference table, right, and then if it doesn't have the corresponding data on the dim products subcategory ID, so it returns a null. So then you have the full outer join. So full outer join is join both tables on the key and return all rows from both tables, filling in nulls for columns on tables which have no match. So this is more complete, what to say, it is full data from table 1 and 2, in this case dim product and dim product category, but it is not going to be complete. You are going to have a lot of missing data depending on all of the join conditions that are there. So then you have your left semi-join. So this is join the left table to the right table and return only the left table columns and only if there is a match. Okay, so this is a semi-join. So you can do a left semi-join, right? So you're returning the rows only if there is a match on the right table. In this case, your dim product subcategory. Then you have an anti-join, right? So these two are new. These are not covered in the first set of joins. So there is anti-join. So returns value from the left side that has no match with the right. So the left semi-join and anti-join are sort of together does the left join, right? So it is also referred to as the left anti-join, as the name suggests. So if I want to run this, so this comes with the keyword anti-join, right? So wherever there is no match, that is what gets returned. All right, so next we'll move on to your SQL function. So there are two kinds of function. We'll talk a little bit more about SQL function later as well. So in this, we are going to talk about scalar function, which are built-in function, which operate on one row at a time, and some aggregate function, which is done over a group of rows, right? Your sum, your count, etc. Right? So other than that, SQL also has user-defined function, UDF, which we'll talk about later. Right? So, so in this example, some of the common use cases of your scalar function is date manipulation, because date has a lot of information. If you want to extract the day in the date or the month in the date, etc. So there are different built-in function which we can use. So you can go and refer to the links that are given. So if you want to process your JSON functions, etc., your string manipulation, right? So all of that is very common use case for your scalar function. So here you're selecting the date difference between your ship date and order date as days to ship, and you're creating a format string, right? And then converting the name construct date shipped as JSON. So let's take a look at it. So this query is doing quite a bit. So you are creating a column called to ship, right? And then a message column, which talks about ordered on which day, which is your order day, and shipped on which day. And then we are also creating a JSON which has the date shipped. Okay. So then you can do, of course, as I said, extract year, day of the month, day of the year, and then put multiple case, combine some of these SQL function, right? This is to just illustrate some of the capability of SQL. So this is to give you all of your aggregation function. So aggregation is always when it's done on a group of rows. So then, so you have your year, which gets done on each of the your order date. You are extracting the year and you're grouping by one. So the one here refers to the first element, right? Then you're doing your sum of sales amount, then sum of sales amount rounded to the decimal place, then maximum, min, the standard deviation, all of it. So let's look at it. Right? So you for each year, this is the total sales rounded without the decimal factor, the order count, number of orders that were placed, the average sales, the highest sale, lowest sale, standard deviation, right? All of this information, including the correlation between the sale amount and the unit price. So all of this, you can look at the documentation of Spark SQL to get all of this function. So another very important uh, function that often gets tested while your interviews are SQL window functions. So window functions are where we are trying to do some cumulative sum, right? So how do we go about doing that? So when you're doing cumulative sum, you are specifying. There are three key terms. You specify the key term over, which identifies the start of the window function block of code, and then the partition, which is the data grouping. So the window function works within each partition, right? And then the order by sorts the rows by the specific column, which is critical for things like your cumulative sum. So let's take an example. So in this case, we are creating a sales summary view. So this is extracting the year, month, and the sum of sales amount from your fact internet sales. So very similar to what we have done. And then we are creating a product catalog, again with the category, product, and sales amount, right? So these are the two views we are calculating. So now we are going to use a window function. So what we want to do is we want to select the sale year, the sale month, the total sale, and sum of total sale, and over. So we want to partition by sale year and order by sale month. So rows between unbounded preceding and current row, cum sum, right? So it's a cumulative sum that we are creating from your sales summary where your sale year is greater than 2010. So for every year that is greater than 2010, so we are going to create this cumulative sum. So what is happening here? So you have your sale year here. So your sale, so in 2011, if you go and look at your data, right? So you have your sale month one. So your total sales is this. Your cumulative sales is the same as your total sale. But in month two, you see your total sales is 46335 and your cumulative sum is this number 469824 plus 46335. So your cumulative sum in March, April gets higher and higher and higher, right? And then you sort of reset at the end of the year. So at 2012, the first month, it comes back, right? So this is a very important, especially when you want to see trend or how much jump happens in each month, right? So this is a very important function to know, the window function. Okay, so then let's talk about cumulative average for one row before another. So here we are doing your sale year and sale month, the average of the sale month. Here your order by your sale month rows between one preceding and one following. So you are essentially creating a cumulative average. We call that moving sort of, you're creating a window. So that month, the preceding month and the succeeding month are used to average for that particular month, right? That's your rolling average where your sale year is 2011. So let's take a look at, right? So for your sale month one, so you are essentially 1.5 because you don't have a preceding month. So 1 and 2, 3 divided by 2 is 1.5. So 2 is coming from your preceding. So 1 plus 2 plus 3 divided by 3, right? So you are looking at the preceding and the current month, succeeding month to create this rolling average. So this is also a very important use case when you are trying to look for, if there are a lot of fluctuations in your data, right? So you can try to smoothen. So rolling average helps to smoothen. So then we have the sort of the final one where we are trying to create the top two selling products by product category, right? You select category products, sales amount, rank, etc. So here, this is a SQL within an SQL, right? So this is also a way to write it. So we could have definitely done it as a common table expression, right? So here we are creating a dense rank over partition by category and order by your sale amount as rank. Okay, and then we are looking at all the ranks which are less than or equal to 2. Okay, so here we see that based on the sale amount for a particular category, so sales amount here it's higher, so it's rank 1, rank 2, then for bikes, your mountain bike has the higher rank, right? So here, of course, we are looking for rank which is only 1 and 2 rank is being listed. Okay, so I think there are a few other SQL deep dive that you can also look into it if that is of interest to you. So one is entile. So take a look at it, and then your set operators, right? So the whole idea is not to walk you through because there are too many SQL functions, but to start, get you to practice some of the SQLs, and maybe in your assignment, you can also use some of these extra operators, etc. So especially the set operators when you want to do union between two queries, etc. Right? Union or intersect, etc. So please do take a look at it.
So let's summarize what we have seen in this module. We got introduced to Spark SQL Lab. So we started with the data set and the business, the AdventureWorks data set, and what are the business needs, right? So how are the sales and customer behavior like, so that they can predict what the customer will buy, right? So then we looked into Databricks in terms of how do we load the data into your SQL tables, views, and create create queries to create your tables, views, and your common table expression. And then we also looked at how do we some review of your SQL features like your joins, functions, and set operators. Thank you. I'll see you in the next video.